Today, we're working with inscribed angles again, but more accurately, we are going to be working with inscribed polygons. A polygon is an inscribed polygon if every single one of its vertices, by the way, vertices is the plural of what word? Vertex. If every single vertex of the polygon is sitting at the edge of the circle. This is an inscribed pentagon here. Now, when you have an inscribed polygon, they generally say that the circle is circumscribed around it. I'm not focusing on the word circumscribed, hence the reason it's not on there, but not on there as a vocab term, that is. But that, if I tell you a circle circumscribes a shape, or if I tell you a shape is inscribed in a circle, I'm just saying two different ways to say the exact same thing. Now, there are some theorems that focus in on inscribed shapes. Specifically, we're going to talk about inscribed triangles and inscribed quadrilaterals. If a triangle is inscribed within a circle, it is possible that that triangle is a right triangle, but only under one circumstance. If I have a triangle hanging out inside of a circle where all of its angles are inside, and I look at one of the angles, if I'm saying it's a right triangle, I'm looking at the right angle. What's the measure of a right angle?
90.
This would have to be 90 degrees, but the only way that it makes sense if that is 90 degrees is if its arc has what measure? 180. Its arc would therefore have to be a semicircle, and therefore the endpoints of its arc would have to be on a diameter. So, a right triangle is inscribed in a circle if and only if the hypotenuse is a diameter of the circle. So, triangle ABC is inscribed in the circle. And is a right triangle if and only if AC is both a hypotenuse and a diameter. If that side is the hypotenuse, that means this angle has to be the right angle. Much like we do with many things. This theorem allows us to create equations that we can work to solve for things. We're going to find the value of the variables, rounding answers to the nearest hundredth if necessary, which means, what are you going to need today?
Gee, guys, look how many calculators running.
Thank you, I appreciate you.
Boy, who else? Who doesn't have a calculator?
Miss Benson, I don't have a calculator. I think I should go up there.
Yeah, you should take a few steps to go grab a calculator, Miss Benson.
Can I go home?
Jasmine,
Wait, ready.
do you have a calculator?
She has her own.
Cap.
She actually has her own. I know she has her own.
Nate, do you have a calculator?
I have a calculator. I always have a calculator. What? This is, I do that.
Which one of you scoundrels still doesn't have a calculator?
Two.
Stop throwing
I
calculators.
passed it to you, Nate. Why didn't you pass it? corners.
I don't mind trying.
Hey, don't worry, I got one of my bag right
But you do still that one for all day.
here.
You didn't even get up, Charlie. Where'd you get that?
That's so creepy.
You just call it Ava.
How would I would freak out if I woke up.
That's the point.
Hey, cool, Charlie.
Get the heart racing a little bit, you stay awake. Okay, so now that we've got calculators,
Miss Benson, I'm scared of the storm.
that sucks. It's not gonna come and get you.
Yeah, it is. We're being hit by lightning.
Would you protect us from a lightning strike?
No. Okay, so we got some triangles inscribed in circles here. Can you see that these triangles are inscribed in the circles?
Yes.
I hope so.
Yes.
Is that an inscribed triangle?
Yep.
Is that an inscribed triangle?
Yes.
No.
No, it's
Not.
not.
Uh-oh.
All three corners gotta be on the edge. Inscribed triangle.
Yes.
Yes.
Inscribed triangle.
Oh.
Okay, so these are inscribed triangles. Every single one of their corners is on the edge. Now, the other thing you have to pay attention to is what kind of triangle they are. What's our favorite kind of triangle?
Right triangle.
Should be a right triangle by now. Is this a right triangle?
Yes.
Yes.
How do you know?
The thing.
The thing.
The thing.
Is inscribed triangle a polygon?
Being an inscribed triangle does not make it a right triangle.
Polyway diameter.
It appears to have a right angle, but you can't tell it has a right angle. Nate, what did you just say?
I said the thing.
You didn't. You said an actual word that was not thingy. Started with a D.
I don't remember what I said.
Oh, diameter.
Said diameter.
That's spooky.
Okay. Do you see that one of the sides of the triangle is a diameter? Y'all, hey, we gotta lock in if you're wanting some work time. Do you see that one side of the triangle is a diameter? That's what makes it a right triangle. It's inscribed and one side is a diameter. That side that is a diameter must also be the hypotenuse. Therefore, which angle is the right angle?
5x.
The one that's marked as 5x. I want to solve for x. Generally, what do you know about the angles of a triangle? They all add up to 180. Do I know anything about any angles except for the 90 in this one?
No.
No. So I'm going to focus in on that 90-degree angle. But here's the thing. That 90-degree angle has a 5x in it.
So 5x.
So 5x better be equal to 90. This is why we got calculators. 18. Okay, problem B. Is the triangle inscribed?
Yep.
Yes. Is it a right triangle?
Yep.
How do you know it, Ava?
Diameter.
Diameter is one of the sides. If the diameter is one of the sides of the triangle, then, Jocelyn, which angle is the right angle? Yes. That makes solving for x really easy. What's x? 90. I like that one. Connor, how could we solve for y? And do what with it? Yes. You can add 90 and 40 and subtract that from 180. Or more commonly, you've been seeing me do this. I take the 90 and I take away both the 40. Sorry, I take the 180 and take away both the 40 and the 90.
50. Oh.
It's pronounced 50. It is not a rapper.
Biddy. Biddy, honey. Biddy, man.
Colin, you're funny, man.
Okay. Problem C. Is that an inscribed triangle? Trey, is it a right triangle? How do you know? The diameter is one of the sides.
There you go.
He's cheering people on.
Yeah,
Hey,
it's just done somewhat condescendingly.
Wing Crew told me I gotta cheer for everything.
Yes, but just do it in a less condescending manner. Cam, which angle needs to be the right angle in this one? And for the sake of ease, I'm going to call that one A, I'm going to call that one B, I'm going to call this one C. C is our right angle. Lily, how can we solve for X?
2x minus 6 equals 9.
Ooh, but is that 2x minus 6 pointing to the 90-degree angle?
Ooh.
Ah.
It's pointed to one from across.
I thought it was pointed to that one.
And I kind of figured that's where you did. So, take a minute to regroup. How can we solve for X? What do you know about angles of a triangle? Do you know something about all three angles in this triangle? So I can add them up and set it equal to? Exactly. I knew you knew it. You just gotta keep a close eye on those arrows. So, one of the angles is 35, one of the angles is 2x minus 6, and some of y'all are still doing this. You're then saying equals 180, but what are you missing?
90.
Don't forget the 90. Brody, I want to solve. What do I do?
Minus 90.
Sure. It's not the way I'd approach it, but it's not wrong. 35 plus 2x minus 6 equals 90. Jasmine, what would you like to do now? Minus 35. Again, not what I would do, but it works. 2x minus 6 is equal to 55?
55.
Biddy.
I'm gonna kick you out of this class.
You can't, you can't
I'm
do
gonna
that
kick
for me.
you out.
I thought we were on the same side.
Aiden, now what?
Plus 6.
Sure. That's exactly what I would do. 2x is equal to 61.
We're all good on
Kylie.
Miss Benson.
How do I finish? Divide by 2.
That's exactly what I would do as well.
Me
Yeah.
too.
Me too.
I get 30.5. Was there a faster way to solve this?
Oh yeah.
Yeah, you could've
I
combined
know
the
it's
numbers.
do this, but
Combine some like terms and then subtract. But hey, this works. Okay, so that's triangles. Let's flip the page. We're also going to inscribe some quadrilaterals. What makes a shape a quadrilateral?
4 sides, I think.
It's got 4 sides. Not 4 congruent sides, not 4 specific sides. There's 4 sides. It's enclosed in. They're straight sides, technically. So there is a little bit more to it, but that's about it. A quadrilateral is inscribed in a circle if and only if the opposite angles are supplementary. Greta, do you remember what supplementary means? That's congruent. They add up to something. Yes, it's two angles specifically that add up to 180. That's what it means to be supplementary. What does it mean for the angles to be opposite? Like E would be opposite of which one?
G.
E would be opposite of G. And those are going to be supplementary, which means the measure of angle E plus the measure of angle G is going to be equal to 180 degrees. Is that the only pair of opposite angles in this shape?
Nope.
And the measure of angle F plus the measure of angle D is also equal to 180. Is this an inscribed quadrilateral?
No, this isn't the four sides.
It technically does. I'm just terrible at drawing.
Yeah, I know.
No. That corner that's hard to tell is a corner is not on the edge. How about that one?
No.
No. How about that one?
Yeah.
Yeah.
Yay.
Woo.
Okay, all four corners must be on the edge for it to be an inscribed quadrilateral. If it is an inscribed quadrilateral, the opposite angles are supplementary, meaning they add up to 180. I want to write an equation to solve for A in this first problem, which does have an inscribed quadrilateral. I find A right here. Haley, how do you think I could write an equation to solve for it? Okay, let's start with this. Since it is a quadrilateral, I need the opposite angle. Which angle is opposite of this one? Beautiful. And those two, since they are opposite, they will add up to 3A plus 111 equals 180. Elena, walk me through solving that.
Subtracting 1.
And now what?
Divided by 3. 23.
Beautiful.
I got the same answers.
Am I done with this problem?
Nope.
Why not?
Just have to find B.
Still have to find B. There's two variables in this problem.
This one's easy to find.
Dominic, can you help me write an equation to solve for B? B's right here, right? Which angle's opposite of it? According to the theorem, what do those two angles have to do? Add up to 180. So I do the first one plus the second one equals 180. Ava said this one was easy. Is it? Once you got the equation, yes. As long as you know how to write the equation, subtract 65 and we get beautiful.
Did you do that in your head?
No.
I was like, wow.
Capable for her to do it in her head.
Independent one.
Next problem. Is that an inscribed quadrilateral?
Yep.
Yes.
Probably.
All four corners are on the edge. Charlie, can you help me write an equation to solve for C? Yes.
I think you have to start.
Start with finding C. I see it here. If it's quadrilateral, I also need its opposite. Which angle's opposite of that one? And according to the theorem, what do those two angles do? Tell me what to write. You know what U is?
Yeah.
So, I'm not going to write U, I'm going to write 2C minus 6 equals. Exactly. This had parentheses. Do I need the parentheses here?
No.
Not unless something was happening to that, like a times or an exponent. And in the formula, it just says plus the angle. Plus, not the somethings we're looking for. Where do I start in solving?
You combine like terms.
I would do that. Thank you. 3C minus 6 equals 180. Then we should add 6. 3C is 186, and then we divide by 3. C is equal to 62. Woohoo. BG, can you help me write an equation for the other variable?
C plus 10x minus 8x.
Nope. The theorem says opposite angles will add up to 180. Find one of your variables. We're going to try to solve for x. And find its opposite angle. Which angle's on the opposite side is this 10x?
8x.
Those are opposites, so according to the theorem, they'll add up to 180. So what should I write?
10x plus 8x equals 180.
Exactly. If I want to solve this, what do I have to do first?
Combine like terms.
Combine like terms. It's not optional here. That is what you have to do first.
I wonder what we get Miss Betsy.
I think it's 10.
I think you're right.
I also think it's
Okay. Last problem is going to have something a little bit harder to it.
oh, there's
The first part of it isn't really any harder. It's doing the same stuff. Specifically solving for the y's. Those are opposites. Y plus 5y equals 180. And we can solve. I'm going to just do this one quickly because for the most part we've practiced these ones. The problem is the other pair, because there's another variable here and it's x. What's the issue? We don't have its opposite angle. The lines I'm drawing aren't like actual lines, they're just arrows. I'm gonna have to use something else. What else do you notice is in this picture that wasn't in others? The 62 and the 80, what are those things? Those are arcs. I know this arc, and I know this arc. Here's the thing. An inscribed polygon is made up of a bunch of inscribed angles. The angle that I want, the angle that I'm missing, I should say,
Perfectly lines up. Look at that.
has those as its intercepted arc. What is the measure of the arc from here to here?
43,
Where'd you get that?
80 plus 60.
Exactly. It's a 142 degree arc.
Because the angle is half of the arc.
And the angle is half of the arc. So the measure of that angle, which we'll just call angle Q, is equal to 1/2 times its corresponding arc of 142. That's our formula from yesterday. What's half of 142? 71 degrees. This angle right here is 71 degrees. Is that what I was trying to solve for in the grand scheme? No. In the grand scheme, no. I'm solving for x and I'm solving for y. Already got y, looking for x. But now I know what the opposite angle of this one is. So now I can do the fact that opposite angles of a quadrilateral add up to 180. I would combine like terms. Subtract, and you know how to do this part, hence the reason I'm just going through it. And divide. I think that's 8.
Yeah, it is.
Yes, thank you. So, sometimes with inscribed quadrilaterals, or inscribed triangles for that matter, you might have to use what you know about arcs, and the fact that inscribed angles are half the measure of their corresponding arcs. Is that going to come up a lot? No. Will it come up more than just this time?
Probably.
Yes.